With a built-in computer, new Synsonics Drums means you can play like a pro.
Welcome back to the bench, and today we got a video featuring these Synsonic drums made by Mattel. They were like a toy back in the 80s. You could buy them in Argos, and I was lucky to have one then. I must have been about 10 years old. But they are actually a fully fledged analogue drum machine.
Listen, we're bona fide, we're not from London.
With sequencing capabilities, you can either hit the pads, you had a bit of control for the hi-hat, and the low tom, or this tom here, oh sorry, this one, and recording on them is pretty simple. We can record, say, onto number 1, and it has 2 bars, 4 bars, and you can see that that isn't actually quantized, but if we use these buttons here, we can actually record a quantized beat. And then we can go back to the other beat we recorded. Oh, I forgot to mention, I bought this one first. It was sold on eBay as spares repair. I think I got it for £20. Everything works except this pad doesn't work, and there's a little piezo electro disc underneath which is completely perished. And then I saw this one a couple of weeks ago, really good condition. I got really excited when I saw the battery terminals, which were, it looked like it had never been used, and indeed it is in perfect working order. So I thought it would be interesting, rather than to fix this pad, to see if we can connect it in some way to this drum kit. And also there's a connection on the side here. It's a 5-pin DIN. It's not MIDI, but it has the ability to trigger the kick drum, which is not actually on a pad. You turn it on and off here, and it's basically a 4 to the floor. So yeah, so this connector, you can connect, I think you can control the kick drum, the accent, which is actually the open hi-hat, and there's another foot switch button, and I think there's a synchronized output, so you could actually sync something like a modular to this. Anyway, there's lots of possibilities, and maybe even see if we can do any mods to the sounds to have some potentiometers control some decays or something like that. And the great news is we have a schematic, so we can see how it all works. And this is one of the things that really intrigues me about this product, is how simple it is. We just have a RAM chip, the microprocessor, the sound generating chip, there's some op amps here, the button matrix, here are the piezo discs, the 5-pin DIN, and a little power input. So it all starts when we put 9 volts either from the battery or from the mini jack on the side, and there's a little DC to DC converter, which then gives us a plus and minus 9 volt output and a 5 volt output. So what's interesting is that the pads connect directly to the sound generating chip, but the buttons matrix are connected to the microprocessor. I think we have a data line here, so it can read any of these buttons or any of the pads. The sequencer gets stored into the RAM, and then the outputs from each of the different sounds get added to the stereo bus here, which then comes out to the phono outputs and also to the headphones as well. So the plan is to see if we can put one of these transducers into the drum, maybe change this resistor here to see if we can still trigger the sound generator at a reasonable level.
New Synsonics Drums with a built-in computer. You don't have to be a pro to play them.
Yeah, but I love to anyway.
Synsonics Drums from Mattel Electronics.
I'm going to cut the batteries off. I'm not going to power it from the batteries, so if I leave that there, I know which one is a negative. Okay, I think this is going to be good enough to work with. We'll just have this ribbon cable which comes to the 4 pads here. So here's the PCB. This is the main microprocessor, an LM6402. We have 4K of RAM here. This is the chip that does the analog sounds. I don't really know too much about that. I'll try and do some research. Down here we have the noise generation chip. It's an MM5837, which I believe was also used in the Prophet 5. Electric Druid do new versions of this chip. It's not quite pin compatible, but it might be quite fun, as we have 2 of these units, to try the Electric Druid chip in here and compare the two. And then these are the op amps for the outputs. The pads connect via this connector onto here, and the buttons to control the unit go like that. But I think the first thing that we should try and do is see if we can scope out what happens when you strike a pad before and after those 75k resistors. Okay, these pop out like that. Okay, these corner bits pop out. This is the broken one. Oh, it's actually ripped off the disc there. So we'll take this one off, but first I want to measure a good one and see if we can see what sort of voltages we get off that. So I've hooked up scope probes to each side of this resistor, and I've taken the ground, which I found one I could easily clip onto there, and they're going to the scope grounds. So if we do a single capture on the scope, we can see directly off the disc itself, peaks at about 30 volts, and on the other side of the resistor looks fairly constant. I had an epiphany after shooting that last bit of video, and I decided to move the piezo up closer to the rim. Be an ideal situation where we can play the tom normally and not trigger the analog circuitry, or if we hit the rim, it'd be nice then to trigger as the analog circuitry. That will give us two sounds on this tom-tom. I've got 4 scope probes here, so we can measure the snare drum directly from the piezo and after that resistor, and this wire here is coming in from the piezo from the tom, and we're also going to scope the output directly from the piezo, and this gives me the perfect excuse to play with my Time Electronics Decade Resistor box. And what this basically does is allows me to dial in any value of the resistor, which will then appear on these 2 terminals which I've connected to the board. And if we want to make it more sensitive, we can reduce that resistor value according to taste. So as a base, I'm going to monitor the snare drum. This is directly from the piezo, this is after the resistor. And we can see this exceeds 20 volts here, and this is just shy of 10 volt peak to peak. And if I switch the trigger to the other 2 channels, so it did trigger it, that was good. We can see that it's nowhere near as loud as it was before. This doesn't appear to have changed, so really scoping doesn't tell us the whole story. But what I'll do now is I'll reduce the value of that resistor and we'll see what happens. Okay, so this is 75k. Let's drop that down to 40k. $30k, 10k, it's not bad. Let's try 1k. Yeah, we lost a little bit of control there. So 4k. Well, that's great. It's going to be a lot of fun, I think, if we try and incorporate this into other drums. I think that's all we're going to do in this video, but tune in next time for part 2, where I think I'm going to explore what happens with the jack input. Thanks for watching. We're over 500 subs now, just another 500 to go.
Sony has just announced they're offering a special Black Friday bundle called the Black Friday Bunduru.